Hi guys, Larry here. In today's video I want to show how I modified my sewing machine servo motor to have a wider range of speed control. From the factory, these optically controlled servo motors have a very narrow 1/8 of an inch range of motion for the speed controller, and it makes it very difficult to have low speed control sewing and high speed at the same time. You basically have to choose one or the other. You have to set your motor for a maximum top speed of like 2 or 3 if you're going to sew critical areas. Then you have to set it to another setting for sewing more wide open straight stretches. And then if you want to wind bobbins, you got another setting you reach under there for. And then you want to go back to slow sewing, you have to reset it to a different setting. So it becomes a yo-yo back and forth, and it's a real pain. So this modification gives you the best of all. You can have slow speed control, high speed, all without touching your digital panel on the servo motor. And you don't have to worry about modifying your servo motor that you're going to screw up your warranty or anything, because all it is a piece of paper, pencil, and tape. I'd like to take credit for this mod, but I can't, because another member over at leatherworker.net by the name of Dave, he goes by DDAHL, DDAL, DDAHL. I'll post details of all this, the link to the Leatherworker post on this, plus anything that I forget or miss in the video here. I'm going to also post photographs on my website so that you can use those for reference when you're doing the modification. So make sure that you check out the website. There'll be more information in that. But anyway, Dave is the one that came up with this, and my hat's off to you, Dave, big time. Unfortunately, his post kind of went unnoticed. There was only one other post that, said, I think Particle said he was going to try it, but I don't think anyone did. Mostly, I'm guessing it's out of fear that they'd have to modify their servo motor. Well, I do get to take credit for this video and how to. And I think this video is going to show that this is not a scary modification, that anybody can do it, and it should open up the door to making a lot of happy people. This modification is very easy to do, and shortly you'll see. Another thing I want to touch base on here is my Enduro Pro servo motor has a setting called slow start, which was confusing to me when I first got the motor. It still is confusing. The slow start is, technically you would think it's going to take some of the edginess off of the abrupt speed changes. And the manual says that it adds milliseconds to the time that it ramps up speed. Well, so I set it to L9 initially, and I was having a lot of problems with my motor stalling, and I'd have to give it help with the pulley. And one day I was reading through the manual, because I like to read manuals, and I went to that setting and I thought, I got to investigate and try some experiments here. I set it to L0, and I experimented with a bunch of them, 1 through 9, and I set it to L0, and my problem with torque on the bottom end totally went away. It's like a brand new machine. It's like somebody put a bigger motor on it. So if you have your slow start setting set to anything but 0, and well, let's just say if your motor has that setting, make sure that you experiment with it. And I can't say that all brands of servos are going to act the same way, but it sure made a difference on mine. Setting it to 0, it's like 3 times the torque. So anyway, I want to bring a heads up to that. Also, this modification is only going to work with digitally controlled servo motors. I highly doubt, I can't see how it would work with an analog controlled servo motor. So if you have a digital panel on your servo motor, chances are high that this will work. No promises, but chances are high. And as people report in, I'll update the web page to successes or failures or whatever with different brands. We can keep a running list on this. So I'm going to start off with the stock factory servo so you can see what it's like, how it acts. Then I'll show you the paper pencil modification, how that works. Then a segment on how to actually do the modification. And at the very end, I'll throw in a sample of how the machine sews at the end. And be sure to check out the website in case I missed something or decide to add something later. So hope you enjoy and find this useful. I know I sure have. It's just I'm smiling right now just talking about it. I think this is going to be big. A lot of people are going to be happy. So hopefully you'll give it a try and smile like me. Anyway, let's move on and we'll move to the next segment. Here's an example of a servo motor with no modification. That's the range of motion from nothing to full throttle. There's a small little window at the bottom that you can control, but if you're distracted for a millisecond, you've got a major disaster on your hands. And here's an example of the wasted range of motion. No change in speed whatsoever. So it's all at that very bottom end. Why they designed it this way, I can't wrap my head around it. It makes no sense to me at all. But there must be a reason for it, because it appears and seems that most of the servo manufacturers that are using these digital controls are using this circuit. And maybe they all copied one design. I don't know. Anyway, let's move on and I'll show you the modification and how wonderful this becomes. And here we have a demonstration of the servo motor with a pencil gradient modification. A very smooth ramp up throughout the entire range of motion with no abrupt speed changes. As you can see, it's a very controllable bottom end. Now keep in mind that this gradient works for my type of sewing. If you want your bottom end to not be so soft and to come in faster, just create a gradient that it comes in faster. It's totally up to you. Very, very customizable. So in the next segment, I'm going to show how the modification is done, and I shot this out of sequence. Luckily I did, because I forgot to show how to take the mechanism here off. So there's 4 screws, one in each corner. Just remove these screws. Take your pitman arm off first, obviously, and this mechanism will just fall off. Not fall, it'll just come off. There's a group of wires that it will hang from. Nothing to worry about as far as electricity or anything. There's no exposed contacts. And you'll see in the next segment that what that looks like. So just take your 4 screws off. That panel will come off and give you access to the optical controller, and from there you can proceed with your mod. One other thing I need to touch on here is the gradient controls the maximum top speed also. So your motor, like this motor here, can go from 0 to 38 or 1 to 38. And right now I have it set at 21, but it's topping out at 17 to 18. And that's because the gradient is only allowing it to go that high. So you kind of have to play with that too. You know, if you really need top speed, you're going to have a bigger black area of the gradient for a higher top speed. Right now, if I set the motor at 10, it will slow down to around 11. It doesn't coincide exactly with the speed on the motor, but it will limit it. So if you need to, cap your speed at, let's say, 8 or something, you can set your motor, just keep setting it down 7 or 8 to get whatever top speed that you need. And then at least it does give you some options there. That's about it. I think we can move on to the next segment and you can see how the mod is done. Okay, here I'm going to show you how to attach the paper gradient to the control arm wiper, install it on the shaft, and explain some of the problems and things you need to watch out for. Also, here's an example of the pencil gradient versus, here we go, that's a pencil gradient versus the computer generated. In my opinion, the pencil gradient is the way to go because it allows you greater flexibility in controlling how fast the bottom end ramps up, vice versa for the top end. You can change the shape of your ramp time between the bottom end, mid-range, and top speed easier with the pencil than you can with the computer generated gradient. So I would just say take a piece of paper and a pencil and play until you get what you like. This here gradient that I have here worked absolutely fine for me. So anyway, that's an example. And when you install the wiper, I place the paper on the back side or the bottom side, whichever you call it, and angle it down so that it angles down from the flat side of the wiper. That way, when it comes in contact with the housing here, it will actually rest on the bottom. And I'll give you an example why. If you take a piece of paper and place it, it will change. Right now we're at a speed setting 2, wherever that paper is at. And this is 22 pound HP inkjet printer paper. The paper that you use will have a bearing on how this works. If it's thicker, it will be faster because it will cut, I believe. I'm not totally positive. I should double check that myself. But anyway, if the paper moves closer to the top of the housing, the speed will increase. So you have to be careful where your paper is at. And you could use that to your advantage too. So I mean, experiment. So where the paper is placed in the path of the light will have an effect. And now when you install the wiper, like I said, angle that paper down so that it swipes the bottom. Carefully position it to the housing and then just press your wiper all the way down to the bottom as far as it'll go. Then slowly advance it into the light path and take your actuator arm and move it. And when you get the right startup where there's a little bit of safety margin that it's not going to go, there we go. That looks good for me. There's still a little bit of movement there and it won't fire. And from there, so you can see now this is computer generated gradient and it works fine. And you could at this point add to this gradient with a pencil to change it. I mean, it's got a nice bottom end. Actually, it's a very mushy bottom end compared to my pencil gradient. This is mushier. Slower ramp up would be better to say. Yeah, it's much slower. And now here's an example. This is a slow, smooth bottom end. Look at the movement to get to 5. Now, to change that, take a pencil and watch where the light path is when it's at the point and go, okay, let's add a few pencil lines right in there and it will change it. It will ramp up faster. So play and have fun. And basically that's it. Tighten the control arm wiper blade here and you're done. Put your 4 screws back in, and you're going to be happy, I think. I sure am. Alrighty. Here's a demonstration of the control that you get with the modification. Three layers of heavy denim. Not a big challenge, but want to sew mid-range, no problem. And if we want to open her up, we have full throttle. I couldn't be happier. Okay, for some fun, let's make it a little more challenging. There's 6 layers. And let's try once more. I think we're kind of at the ragged edge here. I couldn't be happier. Okay, I think that about covers it. Hopefully you guys enjoy this, and will give you inspiration to try it. I think you're going to be overwhelmed with joy. I know I am. I love my new machine, and I really love it now with the control that it has. So anyway, leave comments in the comment section. Let me know what you think. Not sure how this is going to work out with needle positioners. I don't know how the back pedal functions on those, but time will tell, because I plan on ordering a needle positioning servo. So when I get that, I'll let you know. Anyway, till next time.